Hello, everybody. Welcome back to the Casual AI Talk series. I should probably say where I've been for the past 2 weeks. I had a couple of exams here and there, a couple of deadlines, so I didn't have any time to dedicate to this. But I'm back, hopefully, more consistently. And as promised, today we'll be wrapping up the first part of this series in terms of general knowledge, and then from the next video, we'll be going over some more AI for SEO related topics and more, so to say, niche topics. Okay, so today, this is essentially the point where AI turned into something that we like, essentially turned everything around for AI. And that is reinforcement learning from human feedback, and which is essentially trying to align LLMs with human preferences. And we'll talk about a couple of different methods, and I talked about RLHF, reinforcement learning from human feedback, and we'll also touch upon this new topic of constitutional AI and address some of the limitations that we have here. So, as we've been talking about these large language models that are trained on large corpora of data, they're not necessarily aligned with human objectives. So they can produce some output that is, for example, toxic, which is biased, harmful, untruthful even, which is what we refer to as hallucination, or just simply unhelpful. And so it doesn't suffice to just say bigger is better. So it's not that when we scale the models, these properties just disappear. And when we're talking about this whole landscape of things, we have to think about 3 dimensions as it's regarded to in the literature. And those are the helpfulness of the model, the honesty of the model, and the harmlessness of the model. And this is commonly referred to as the triple H principle. And so we have to align our models to fall somewhere inside this 3-dimensional grid. And there have been several different ways of doing this, and one of the most important examples that I can think of is the whole backbone of ChatGPT and the RLHF that they brought up. And this is introduced in the InstructGPT paper. And what they do is they have essentially like a 3-step pipeline where they begin by supervised fine-tuning, which we talked about in previous episode. And they have this reward model training process. And finally, they have a reinforcement learning pipeline / policy optimization that they're doing. And we'll go over all of these. So we talked about supervised fine-tuning, and I won't go necessarily into it. So that's step 1. And that would be the starting policy that the model essentially has. It encodes basic instruction following and has some nice perks that we already talked about. So in the reward modeling phase of the training, so training the reward model, we generate multiple candidate outputs from the model. So we prompt the model essentially, and we get several different outputs. And we take a human annotator and ask them, okay, which one do you actually prefer? So you have these 3 options. This is the reference prompt. Which one would you want to have? And you've probably come across this from using ChatGPT, for example, that it explicitly asks you, it gives you 2 examples, and it's like, okay, which one do you actually prefer? Do you prefer A or prefer B? And that's what's happening right there. They're training their reward model. And we take those rankings that the human annotator creates, and we train that reward model. That's what it's essentially doing is taking a prompt and a candidate, and it's assigning a scalar score to it. So let's say, for example, a score between 0 and 1, 1 being the best one and 0 being an awful response, and then approximating essentially whether a human would prefer that answer over another, for example, by comparing the values of the scalars. And in step 3, which I mentioned, we're talking about reinforcement learning and policy optimization. So if you're familiar with LLM literature, or reinforcement learning literature, this is going to be very obvious. But essentially, we treat the LLM as a policy. So let's say a rule. Let's refer to a policy as a rule. A rule that selects a token, or rather a sequence of tokens, and we optimize this process using a reinforcement learning algorithm to maximize the reward the model will get from the reward model. And there are a couple of stuff that we have to consider here. And for the technical folks, because we know that generation is non-differentiable, we can use policy gradient methods like PPO, or other variants it has. And essentially, we're trying to minimize the divergence of the policy that the model has from the reward, and from what is expected from like the reward model. And it's based on some like callback Leibler divergences. But we'll not get into it. So essentially, when you're thinking about it, you can think about it as, we have this reward model that we've trained on human preferences. We have our LLM, which we treat as a policy, and we're trying to get this policy as close as possible to what the reward model is expecting. And that's essentially what reinforcement learning with human feedback is doing. And that's what they're doing in the InstructGPT paper. And there are a couple different additions to this whole recipe. So, for example, you can mix in pre-training data to avoid a phenomenon referred to as catastrophic forgetting. So the model doesn't lose the abilities that it already had. You can, for example, calibrate the reward scale. So I referred to a 0-1 scale, but you could recalibrate that, for example. So you could do clip policy updates as you would do it like in PPO. And there are a bunch of other ones. And there's also something that we commonly see with modern LLMs, is that they have baked-in abstention. So maybe they refuse to completely provide an answer if the prompt is asking for something harmful or toxic. And what they found in this InstructGPT paper, which is pretty fascinating, is that using this pipeline of RLHF, a 1.3 billion parameter model called InstructGPT, which was fine-tuned using this RLHF principle, outperformed GPT-3, which then had 175 billion parameters, which is pretty significant, right? A 1.3 billion parameter model outperforming 175 billion parameter model is huge. And they also found that it lowered hallucination, and it also lowered toxic output, which is nice. There are a couple of caveats and challenges that have to be addressed here. Although that the reward model in itself is not better than its training data. So it's essentially as good as its training data, and the biases that these human annotators bring with themselves can propagate into that model. And this whole pipeline of reinforcement learning, reinforcement learning on its own is very delicate. So the hyperparameters, the exploration space, the stability issues, these are all problems that RL has. And there's always this trade-off between whether you want to push for safer outputs or do you want to still be helpful. So in that Triple H framework of things, there's also a push and pull motion between all these three aspects. And this pipeline doesn't necessarily account for adversarial inputs or distribution shifts, safety vulnerabilities, all that sort of stuff can still happen. Moving away from that, I want to talk about this new field of aligning models with human preferences, which is actually called constitutional AI, which aims to improve harmlessness, so make models less harmful, and improve the transparency and scalability of these reinforcement learning methods. So rather than solely relying on human preferences, you define a so-called constitution. And what is that? So you define a set of principles that your model should adhere to. For example, let's say, be helpful but not harmful, avoid toxicity, be honest, stuff like that. These are constitutions. These are rules that you define for the model. And the model uses a technique called self-critique or internal evaluations against that constitution. So this allows the model to generate preference data, essentially, without having a human annotator. And this method has also a couple other names, but one of the more common ones is RLHF, so reinforcement learning from artificial intelligence feedback, and it's also one of the new methods that has been used. So essentially, you take the human annotator and bring another model in. It boils down to that. The training process is pretty much the same. So you have the supervised phase where you have the base model, and then you make a copy of the model, and that model flags like different suggestions. So it acts kind of adversarially if you're thinking about it in like a GAN setting, kind of. This is me just like thinking out loud. But so one model, you have one base model, going back to what I was talking about. So you have this base model, you make two copies of it, and the other model critiques the responses that the secondary model is making based on the constitution, and suggests improvements and flags issues, for example. And the original model is fine-tuned on revised outputs from the critique model, and outputs a better response, essentially. And the reinforcement learning / preference optimization pipeline that exists there is that the model generates, again, a bunch of candidate outputs. The internal critic ranks them. These rankings then train a preference model, and then the policy is optimized just like you would in like RLHF. And this is an improvement because it has less reliance on human labeling in general. And some extensions that have been added to this, which I'll just name for the sake of people who want to study this, is like the collective constitutional AI, which a community input can shape the constitutional rules, which is kind of one of these like more utopian ideas that exists. And then there are a bunch of other variants. For example, there's a preference optimization DPU, which you might have heard about, or RRHF, ranking based something. I forgot the abbreviation. And these are all meant to improve these alignment pipelines. There are, of course, as I mentioned, a bunch of limitations to this whole idea of improving the alignment of models. So there's like specification gaming or reward hacking, which is commonly referred to. So models might find like really strange ways to hack a policy, essentially. There's the problem of distributional robustness, which doesn't account for the model seeing new examples. There's a human disagreement. We don't necessarily all have the same preferences. It's trying to just model the normal distribution of this data, right? There's the problem of transparency and auditability. Alignment drift is a problem. So the model might not be representative of the global preferences, for example. And there are a bunch of things that you can do to mitigate the downsides of these. So you can use mixed human and constitutional feedback, which is like a hybrid technique. You can do frequent audits of the model, for example. And you can do domain-specific adaptations of these reinforcement learning pipelines for your specific use case, for a specific task. And at the end of the day, you can still maintain that human in the loop feedback to reduce the amount of high risk when you have essentially high risk tasks. But yeah, that's what I wanted to talk about today in terms of alignment problems. We talked about two methods, two overarching goals, about constitutional AI and about reinforcement learning from human feedback, or actually the other way around. And by now we've together built this pretty good foundation to work on and to build on in terms of knowledge. And from the next video, hopefully we'll be diving deeper into topics that are more related to AI for SE. Today's video was a general topic in a sense. So I hope you tune in for the next episode. If you like this one, like, share, subscribe, connect, or whatever. And hopefully I'll see you in the next one. Cheers.